Okay guys, I hope you have a lot of paper in front of you, a nice sharp pencil or a really good pen, because we are going to be doing our final exam review, and we're going to start with Unit 1, Matter. Okay, now the key thing about matter is we need to talk about what matter is. Okay, so matter is anything that has volume and mass. Okay, now you might be saying, well, that's cool, but I don't know what volume and mass are. So let's break it down. Okay, volume is how much space is occupied. How much space is occupied. Okay, so if it takes up room in an area, it has volume. Okay, now there are a few ways we do this, or we measure this. So we use instruments to help us measure volume, and those instruments are usually graduated cylinders. Okay, you could also use beakers or flasks, or Erlenmeyer flasks. They all measure them, but graduated cylinders are used more often because they're a little more accurate. Okay, now the units for volume, okay, are liters. Okay, and liters are abbreviated as a capital L. Okay, but you could also have milliliters. Okay, which is abbreviated as lowercase m, capital L. Now, milli, anybody know what milli means? Milli means 1,000. So there are 1,000 milliliters in 1 liter. Okay, so that's volume. But let's talk about mass. Okay, what is mass? Well, mass is how much something weighs. So essentially, if it weighs something and it takes up space, then it's made of matter. And as a corny chemistry pun, you matter because you made a matter. Okay, so how much something weighs. And we measure this with our instruments. We can either use a triple beam balance, that's kind of the more old school way, or you can use an electronic scale. This is more common nowadays. Most people don't use a triple beam balance unless they're in a high school chemistry lab and you're learning how. Most scientists only use electronic scales now because they're a lot more accurate. Now the units for mass are grams, which is abbreviated as a lowercase letter g. So that's the first part. Now, we said that matter, anything that has volume and mass. Well, let's talk more about that. So there are 3 phases of matter. Okay, 3, and I cannot spell. But there are 3 phases of matter. Okay, and we are going to draw a little chart. Okay, so we're going to just put a nice little chart in here for us. So we're going to have our characteristic. We're going to have solid. Let's give solid a little more space. Solid, liquid, liquid, and gas. Okay, now if I'm looking at these, the first characteristic we want to look at is the volume and mass. Okay, so in a solid, it has a fixed volume and mass. This means it's the size, how much space a solid takes up is not going to change, and neither is its mass. Okay, a liquid also has a fixed volume and mass. Okay, if you pour a liquid in a graduated cylinder and measure 15 milliliters, and then 30 seconds later you take the measurement again, it's still going to be the same volume. Okay, whereas a gas doesn't have, or let's just say no fixed volume. Okay, the volume of a gas depends on the container. So it depends on the container. We know that if I were to spray a can of perfume at the front of the classroom, somebody in the back of the classroom would be able to smell it eventually because gas particles move. They take the shape of the container, either the classroom or the aerosol can. They just take the shape. But the mass is fixed. Okay? The weight of that gas, the amount of matter in that gas will still stay the same. Okay? We have that part. Next, let's talk about the shape. Okay, what do these things look like? Well, solid shape is fixed. It's not going to change. Okay, but a liquid is not fixed. Okay, all liquids take the shape of the container that they are in. So, for example, if I pour a Coke into a can, it takes the shape of the can. If I pour it onto the table, it spreads out because there's no walls to contain it, right? And if I have a gas, it also is not a fixed shape, okay? It takes the shape of the container, which is why we have things like balloon animals and just like balloons in general can be any sort of shape that you want them to be. Okay. The next thing that we want to talk about, the next characteristic, is the kinetic energy. Okay. Now, remember, kinetic energy is talking about movement. Okay. It's referring to movement. So when we're talking about kinetic energy, okay, we're talking about which things are going to move fast, which things are going to go slow. Okay, well, gases have the most kinetic energy. Okay, the most kinetic energy. So that means they move quickly and they move freely. Whereas solids have the least kinetic energy. All right, they move slowly. In fact, they move so slowly, they vibrate and they stay in one place. Liquids are kind of in the middle, so middle kinetic energy. I'm just going to say kinetic E. All right. They have medium speed, okay, and they move together. All right, so that means they are flowing. Now, if you think about these in terms of like a second grade classroom, right? When you're in second grade and you're working on math, for example, you're usually sitting at your desk and let's say you're doing your multiplication times tables, okay? Sitting at your desk and you're working on your multiplication times tables. Okay, well, your position is not moving. You're staying at your desk, but your arms are moving, your mouth might be moving, you might be talking to somebody near you, and you might be tapping your feet, right? So you're moving, you're kind of like vibrating, okay, in place like a solid, but your position in the room is not changing. Okay, so that means you're acting like a solid. Whereas a liquid, okay, when the whole class is going to PE in elementary school, you line up in the hallway and your teacher puts you one behind each other, single file. And as you move down the hallway, your position in the school is moving, but your position to your neighbors is not. You keep the same person in front of you and the same person behind you as you're moving. Okay, that's like a liquid. Whereas a gas is like recess. Okay, you're running all over the place. You don't have to stay near the same people and you can go all over. You're moving quickly and you're moving freely. Okay, that's kind of how I remember what they all look like. Now, the last thing that we want to talk about is we just want to get a general picture of what the atoms look like. Remember, matter is made up of small things called atoms. Okay, so let's get a general picture of what these look like. So, atoms for a solid are going to be really close together. Okay, they're tightly packed. They have a shape. Okay, and then these little lines here, this is going to be them vibrating. Okay, these just show they're moving. They are vibrating. Okay, but they're not changing their position. Whereas a liquid, if you were to draw a container, because liquids need a container in order to have a shape, okay, their atoms are going to be a little further spaced apart, but there's not going to be too far away from each other. And if you were to pour out a liquid, the atoms would all move in the same direction. That's what these green arrows are indicating. They're all moving in the same direction. Okay? They all stay kind of together. They all move in the same position. Whereas if we have a gas, let's draw a balloon. Okay? In a balloon, your atoms are really far apart. Okay? And they're moving in all different directions. Okay? They could be moving in the same direction, different directions, but they're all just moving crazy and they're moving fast. Okay? So this is kind of the idea of what is happening with that. So if we just review our chart, okay, is we got these three phases of matter: solid, liquid, and gases. Okay, solids have a fixed volume and mass, a fixed shape. They move very slowly. They vibrate and stay in one place. Whereas the liquids, they have a fixed volume, okay, and mass, but their shape could change. They take on the shape of a container. They have kind of in the middle kinetic energy kind of thing. They move at a medium speed, they flow, but they stay together. They move together. Whereas gases have no fixed volume, okay? They can spread out to fill up their container, and their shape depends on the container they're in. They have the most kinetic energy, they move freely, and they move quickly. They go in all different directions, okay? So now that we've talked about those, let's go in to the next idea, okay? And the next idea is going to be about those solids, liquids, and gases, okay? We've learned about solids, liquids, and gases several times throughout the year, and that's because everything is made up of matter, okay? At least everything that we study in chemistry, okay? So we've talked about the three phases and how you move from one phase to another. And you've seen this diagram probably 8 billion times. That might be a little bit of an exaggeration in class. Okay, so we want to talk about how solids can change their phase. All right, but with that, there are two processes that they use to change. Something could be endothermic, okay, and all endothermic reactions, I'm going to draw in blue, and it means that they absorb heat or they absorb energy, okay, whereas exothermic, which I'll write all of those in red, they release heat or energy. I'm going to put that over here too. Make sure we know heat and energy. Heat is a type of energy. Okay, so let's talk about as I go from a solid to a liquid. If I think about water, okay, water as a solid is going to be ice. Okay, water as a liquid is just water, H2O, right? And as a gas, it's steam. Okay, so in this thing, we're talking about H2O. So as I go from a solid to a liquid, I would melt. So that's melting, right? And it's an endothermic process. I have to put heat into the ice in order to make it melt to become a liquid. Now, the reverse of that would be exothermic, okay? And that would be called freezing. As I go from a liquid to gas, okay, I have to put heat in it. Okay, if I put liquid water on top of the stove and I turn the stove on, it's going to start to vaporize. And I know it's starting to vaporize when I see vapor, when I see evaporation, but especially when I see boiling. Okay, that is an endothermic reaction. The opposite of that would be condensation. Okay, you can see this oftentimes on the edge of your glasses. If you have a cold glass of sweet tea, you'll find water on the outside, and it's not because your cup has a leak, it's because the water in the air around it has been cold enough to go from the gas to the liquid phase. Now, going from a solid to a gas is called sublimation, and I remember that those two go together because when I start at a solid, solid starts with S, and so does sublimation. The reverse of that, oh, and we also see sublimation with dry ice. Okay, when you have dry ice, it goes straight into a gas form, which is why it's called dry. It skips the liquid phase. But the reverse of that is called deposition. Okay, and that is an exothermic reaction. All right, so the next part of Unit 1 that we talked about, we're going to have a chart again. Hope you're all right with that. Is we talked about the difference between physical and chemical. Okay, now with physical and chemical things, we have physical and chemical properties, and we also have physical and chemical changes. So let's talk about the difference between these. Okay, so a physical property is a characteristic that can be detected using your 5 senses. Okay, so some example of these would be color, shape, mass, volume, odor, texture, All of these are examples of physical properties. Okay. Now, the difference is a chemical property is a characteristic that can only be detected during a change. So, what that means is some examples would be flammability. Okay, if I say something is flammable, it means that it can light on fire. Okay, well, I don't know if something's going to light on fire until I try it, right? So I can only, if it catches on fire during that change, I'm like, oh, it's burning. Okay, that's a change and it's happening, so that must mean it's flammable. That's a chemical characteristic. The ability to rust. Okay, I don't know that my bike can rust until I leave it out in the rain and outside, and then I realize, hey, it starts to rust. Okay, corrosion. Okay, corrosion or corroding. You might have heard a battery corroding. That's a chemical property. Okay, when a battery corrodes, you see it as like the battery of a car. If you've ever had to scrape off the stuff at the on the battery, like the chemical gunk that gets on there, that's corrosion. Or if you've left batteries in a calculator or in your remote or something like that too long after they've stopped working, they'll almost like kind of explode, right? It's a chemical reaction that's happening, and so that ability to corrode is a chemical property. Okay, so properties are characteristics. That's the key word here. Properties are characteristics, okay? And what's the difference is how they're detected, okay? So let's talk about changes, okay? Well, a physical change is a change that does not affect the chemical composition. And you're like, Ms. Nichols, what does chemical composition mean? You're using these like big fancy science words. Well, the chemical composition is essentially the identity. So for example, okay, when I go from ice to water, okay, we call that melting, all right? But it doesn't change the identity. It starts off as H2O, and after it melts, it is still H2O. Okay, that's a physical change. Other physical changes could be folding or ripping paper. Okay, it's still paper. Before and after, it's just a little bit different. Okay, or a haircut. That is also a physical change. Now, some of these things are reversible changes. So for example, folding, I can unfold it. Okay, I can freeze something that has been melted. But if I rip the piece of paper again, I can't put those two pieces back together. Now without tape, so then it's still changed. Okay, a haircut. If I ask for a trim and they cut off 10 inches of my hair and I'm now bald, I can't do anything about that. I have to let it grow out. Okay, I can't reverse what they did. Okay, now a chemical change, it changes the chemical composition, which we know now means the identity. So, for example, okay, burning paper. At the beginning, we start off with paper, and at the end, we have ash and smoke and things like that. A car rusting, rotting food, right? If it starts off a banana, it's not going to end up a banana at the end. Digestion is a chemical change, and so is baking a cake. All right, but let's say I change the color of a house, right? If I paint a wall, okay, I've changed the color, but it's still a wall, okay? That makes it a, oops, put that in the wrong column. painting a wall would be a physical change. It changes the color, but it is still a wall. Okay, so this is our kind of chart about physical and chemical properties and changes. They were a big part of Unit 1. Okay, the next really big part is this thing called density. Yay, density. Okay, now density is equal to the mass divided by the volume. Okay, now because it's like this, we know it's a ratio. Okay, this means a ratio. Oops, not ration, a ratio. All right, now density can tell us a few different things. First of all, the units are grams per milliliter. Sometimes you see it written sideways, grams/milliliter. Okay, now the cool thing is the density of water, so the density of H2O, is 1 gram per milliliter. So this means if my object has a density that is greater than 1 grams per milliliter, that means it's going to sink in water. But if my object's density is less than 1 gram per milliliter, that means it would float in water. So that means you could create this cool thing called a density column. And you could have a layer of red stuff. You could have, oops, somehow managed to erase my column. You could have a layer of blue stuff, a layer of green stuff, a layer of purple stuff, a layer of yellow stuff, and the things that are here on the top would have the lowest density, whereas the things that are on the bottom, the things that sunk to the bottom, would have the highest density. Okay, so let's work out a problem, because you're like, okay, there's formulas, there are units, that probably means I'm going to need a math problem. And you're right. So let's work one of those out. Okay, so let's call this one problem number 1. Okay, so let's say in this problem it says if the volume of an object is 25 milliliters and has a density of 1.4 grams per milliliter, what is the mass? Okay, well, if that's the case, the first thing we do is we can use this method that I like to call the guess method. Okay, G stands for given, U stands for unknown, E stands for equation, the first S stands for substitute or plug in, and the last one stands for solve. So let's follow this method to solve our problem. So let's write down first what is given. So these are my givens. In my problem, I'm given this number in unit, I'm given this number in unit. So I know that milliliters measures volume, and it says if the volume is, so that means my volume is 25 milliliters, and my density is 1.4 grams per milliliter, right? My unknown, okay, those are my two givens. My unknown is what I'm looking for. okay? What I'm trying to find. So, it says, what is the mass, okay? So my unknown is my mass. Mass is equal to a question mark in my brain. We don't know. That's why there's a question mark at the end of our sentence, okay? Well, what is our equation? We know that our equation is going to be density is equal to mass divided by our volume. So then the next part is substitute. Now, normally when I'm working out these problems, I don't write out given, unknown, equation, substitute, solve, but I just do them all. If you can hear that bell, it's because it's 3 o'clock on Friday and I'm making your video. Sorry for that interruption. But if we substitute, that means I'm substituting in my values. So I know my density. My density is 1.4 grams per milliliter. And I know it's equal to my mass. I don't know that, so I'm going to leave it as an M. And my volume is 25 milliliters. Now, to solve for mass, I would cross multiply. Okay, so that means, oh, and sorry, I'm skipping a part. This is where we would solve. Okay, so now we're going to solve. I would have 1.4 grams per milliliter times 25 milliliters is equal to my M. Now, when I'm looking at this, my milliliters cancel out with my milliliters. So I know that my mass is going to be equal to something with grams, which is excellent because I know that grams is the unit for mass. And when I multiply these together, I'm going to get 35 grams as my answer. Okay, so I'm only going to do one problem. If you want more practice problems, come see me. They're on the e-class page from last semester, and you can look at them there. There's also a video on my YouTube page just all about density, so you can check that out as well. Okay, and this is the conclusion to Unit 1. If you have any questions, let me know. But otherwise, move on to the next video, which will be all about Unit 2.